record on this computer. Okay, now we are recording. Okay, very good. And then now we will share. Okay, so from last meeting, we started to discuss the Denavit-Hartenberg examples. Now we will continue to discuss at least two examples, and then we will move on to the last topic. So we discussed this. Which one did we discuss? This one, the planar one. Yeah. Now we will discuss this and this one, and then that's it. Yeah. The rest you can look at it yourself. Okay. I have here the convention so that we can have them handy. And okay, let's proceed. So what we did before, again, we will always assign the axis. We started it already. I think, yeah, this is Z0. The second joint, Z1, there are just 3 joints. And the third joint, Z3, is a prismatic joint. So this is Z0, Z1, Z2, as well as the same direction as Z3. Okay, and then that is what we say, joint I rotates about the ZI axis. So joint 1, this is joint 1 rotating about Z0, joint 2 rotating about Z1, joint 3 translating along Z2, and Z3, of course, is your end effector Z axis. Now you have XI is a common normal and intersecting to both ZI and ZI minus 1. So where is XI? So now we say that we have to first assign the base frame. So that if that is your Z, so we assign that our X0 is here and our Y0 is here. Okay, you can assign it anywhere you want. Okay, so we just find that it is convenient to do here. It's fine. So now we need to know where is your Z1. So that, sorry, this is, okay, X0, Y0, and Z0. And that is the right-hand rule. Okay, now this is your Z1. So we need to define where is your X1. So X1 has to be perpendicular to Z1 and intersecting. So this direction is possible. Okay, okay, I will mark it. This is possible direction of Z1. I mean X1. This is also possible direction of X1. Okay. But because we need X1 to be both intersecting and normal. So this is intersecting already. This is intersecting Z1 and normal to Z1. That's fine. This is intersecting Z0. Okay. And normal to Z0, so this is a possible X1. So where is our X1? Maybe we choose X1 to be the positive direction here, okay? Because X0 is here, X1, like that, okay? So that's one possible X1. But we say that X1 can also be here, okay? This is also a possible direction because this one also intersects Z1 are perpendicular to Z1, you know, so that is okay for X1. But is it intersecting and perpendicular to Z0? It is not intersecting, but they are coincident, no, exactly the same axis, and it is not perpendicular. So this one is not possible. Okay, so our X1 here is correct. So next, where is your X2? Okay, maybe I'll choose another color. So you have your Z1 here. Okay, you have your Z1, and so we need an X. So X can be, again, it can be in this direction. Okay, there's a possible direction of X. It could be in this direction also. Okay, and then we check. if we choose this one to be our x2, if this direction will be our x2, where is your z2? Z2 is this one. It's perpendicular and intersecting. It's okay. So what about z1? It has to be perpendicular to z1 and intersecting. So is this perpendicular to z1? Yes, it is perpendicular to z1. Is it intersecting z1? Yes, it's correct. It is intersecting z1. So we can assign these to be x2. What about this one? Is this perpendicular to z2? Yes, that is perpendicular and intersecting z2. Yes, but is it perpendicular to z1 and intersecting to z1? No. So this one, if you assign this one to be x2, this cannot be. Okay, so our x2 is there. So now we say that because this is our, we say that the n effector axis, if this is your z3, then we can choose our z3, okay, because it moves somewhere. Maybe there's a link here like that. We can use our x3 to be at the tip of that link. Let's say, for example, this one is our x3, and we say that is again the same direction as your x2, the same direction as the x3, and z2 also the same direction as z3. Okay, normally. So it's just for easy reference. Okay, we will copy the n-1 reference frame to be in the same direction as the nth frame. Okay, now we have those frame assignments. Now we look at the DH parameters. Okay, let me just erase some of them so it will be easier. We erase this. Okay, and let's erase. Let's make it clear. So it was x1 here and x2 there. Okay, and then that is your x3. Okay, now, okay, so, well, the most critical ones are the z and the x's, okay? Why we can just disregard it this time. So now let's continue. We say that theta is about z, theta 1 is about z0 from x0 to x1, okay? So where is theta? So this is theta. And now this is, of course, okay, this is, of course, a variable, theta 1, and theta 2 is also a variable. But then the variable for the other one is not theta. For the third link is not theta, but d3 is the variable. So that's that one. But anyway, we assign it as a variable, but then these have some values. Okay, so what is theta 1 value? About z0. So about z0 from x1, where, I mean, from x0 to x1. Where is x0? X0 is in that direction, and x1 is also in that direction. So is there any rotation with respect to z0? x1, x0, and x1 are parallel. So there's no rotation, so this is 0. The value of theta 1 at that time is 0. I mean, in this configuration that is being shown. Okay, now next we put theta 2. So theta 2 will be about z1. So where is it? Z1. This is z1, and theta 2 is rotating around there. Okay, maybe I should put that one there. The same thing as theta 1. Theta 1 is rotating there. That's theta 1. And this one is moving there. That's d3. Okay, so let's, sorry. This is theta 1, and this is theta 2. Okay, joint 1, theta 1, joint 2, theta 2, joint 3, d3. Okay, those are the variables. So now let's start. Theta 1, we say 0. For theta 2, we say theta 2 is about z1. So about z1 from x. Okay, from, what is this now? From x0, or from x1 to x2. Okay, So about Z1, because from about Z1, from X1, where is X1? This is X1 to X2. Where is X2? X2 is also in the same direction. So from about Z1, from X1 to X2, where X1 and X2 are both parallel. So again, this is 0. Are parallel, I mean the X1 and X2 are parallel to each other. So now, what about theta 3? So where is theta 3? In this case, theta 3, the same thing. It is still about, this still applies, but now theta 3 is not a variable. It is a constant. So we say theta 3 is about Z2. Where is Z2? There's Z2. And about Z2, so from, okay, where is that? From X2 to X3. So where is X2? There's X2. And where is X3? That's the same thing. There is no rotation about Z2 from X2 to X3. So this is also, that is 0. That's correct. Okay, so we are done with the thetas. Next, let's go to the alphas. So alpha 1. So about, in this case for alpha 1 is about X1. So where is your X1? X1 is here. Okay, so about X1 from Z0 to Z1. So where is Z0? Z0 is there. Where is Z1? It's here. So now listen, this is very important. So if that is your X1, okay, you put your thumb on the X1 and then put these four fingers, the four fingers along Z0. Okay, there. So X1 there and Z0 is here. So from Z0 to Z1. So you twist there in this case here. So it's in the negative direction. Okay, it's positive direction is going there, but Z0 is there, and then you go Z1. Can you do it, all of you? Okay, put your finger along X1. Come on, put your fingers up. Put your finger along X1. Okay, and then now all these four fingers are pointing along Z0. Do you see that? Okay, so X1 is in this thumb and Z0 is in the four fingers. So now we rotate about Z1 from rotate about X1 from Z0 to Z1. So rotate and then to Z1, where Z1 is there. Okay, and that's 90 degrees. So that is negative. So this is correct. Minus pi over 2. Okay. You see that? Okay, that is correct. So next, again, alpha 2. So about X2. Where is X2? X2 is here. So from Z1 to Z2. So again, let's do it. X2, your thumb along X2. Okay. From Z1. Where is Z1? Z1 is here. Z1 is in the horizontal. So X2, Z1 like that. To about X1 from about X2 from Z1 to Z2. So it goes like that. So it's positive direction. Okay. Do you see that? Put your thumb. Okay, come on. Do it. Your thumb X2. Come on, put your thumb on X2. I want to see your thumb. Okay. Okay, bite your thumb. Bite your thumb. Bite. Your palm should be flat because it's the direction of Z1. This one should be flat. The palm should be horizontal. Your palm should be horizontal because it's in the direction of Z1. Okay, horizontal. Your palm is not, it should be horizontal. Horizontal and then move, sweep to become vertical there. From X2, from Z1 to Z2. Okay? Okay. You can only see it when you bite your thumb. If you don't bite your thumb, you cannot see it. Okay? Okay, there. So I guess this one is clear. So that is positive pi over 2. Okay, now let's go alpha 3. So alpha 3 is about x3. Where is x3? X3 is here. Okay. About x3, again, x3, put your thumb there, and then from z2 to z3. Well, it's very clear here. Z2 and z3 are coincident, and there's no rotation. So this is 0. That's correct. So we're done with alpha. Okay. So let's go to A. So A first, because here is a variable. Okay, I want to do it last. So let's go to A1. So A1 is along x1. So where's x1? So this is x1. Along x1 from intersection of z0 and x1 to origin of frame 1. So z0, where is z0? Z0 and x1 intersection is this one. Okay, that's the intersection. From that intersection to the origin of frame 1. Where's the origin of frame 1? This is also the, okay, maybe I should label it first so that we can see it clearly. Okay, this is origin of frame 0. This is origin of frame 1. This is origin of frame 2. And we choose our origin of frame 3 to be here. Okay, there you go. So now we can look at the origin now. So along x1, so this is your x1 from the intersection of z0 and x1. Intersection of z0 and x1 is this, that one, to the origin of frame 1. So to origin of frame 1 is the same. They're coincident, so that is 0. Okay. Next, A2. A2 along x2. Where is x2? x2 is here. So again, x2 origin, x2 intersection of z1 and x2. So x2, and where is z1? This is z1. Z1 and x2 intersection. This is that one. And to the origin of frame 2, where the origin of frame 2 is this one also. So they're coincident. So there's no distance. The distance is 0. Okay. Next, A3. So A3 along x3. Where is x3? This is x3. So intersection of Z2 and x3. So Z2 is this one and x3 is this one. That's the intersection. And then to the origin of frame 3. Origin of frame 3, they're coincident. Again, that is 0. Okay. So we are done with the A's. Okay, now let's go to the D's. So D1 along Z0. Where is Z0? This is Z0. From origin of frame 0, origin of frame 0. Okay, let me change the color. Origin of frame 0 is this one. Okay, to the intersection of Z0 and X1. To the intersection of Z0, this is Z0 and X1. So this one. So it is along Z0. So along Z0, so this is from along Z0, along in this direction, from the origin of frame 0, origin of frame 0 to the intersection of this one, Z0 and X1. So from here to there along this one. So because from here to there along that, that's a positive direction. So this must be positive. Okay. But this distance is not assigned. It's not assigned here because the frame that they put the frame here in this point. They put the frame 0 at that point. But for us, we put the frame 0 here. So that means this one has some distance D1. Okay, it is not 0. Okay, so this one will have D1 distance and it is positive. Do you understand? Along Z0 from origin of frame 0, this is origin of frame 0 to the intersection of Z0 and X1. This is the intersection of Z0 and X1 from here to there along there. So that's D1 positive. Next, D2. Okay, for D2, along what is this now? Z1. Where is Z1? This is Z1. Okay. So along Z1 from origin of frame 1. Origin of frame 1 is this one. Okay. From origin of frame 1 to intersection of Z1 and X2. So intersection from here to intersection of Z1 and X2. X2 is here. So the intersection is here. Okay. X2 and Z1 intersection here. And origin of frame 1 is there. So from frame 1 origin to intersection of Z1 and X2, that one. So along in this direction. So that's positive. So what is this? D2 positive. That is correct. That distance is D2. Okay. Now here, along Z2. So Z2 is there from origin of frame 2. Origin of frame 2 is here. Okay. To the intersection of Z2 and X3. So Z2 and X3 is here. That's the intersection. Okay. From origin of frame 2 to intersection of Z2 and X3. That's that one. So from here to there along is the direction. So that's positive. Okay. That's positive direction. And the distance is D3 from here to there. We assign that to be D3. That's a variable. It can be short or it can be long, but for now, that is D3. We are done. Any questions? So again, after you derive all the 4 parameters of the Denavit-Hartenberg Convention, then you can now apply 0, the transformation matrix, 0 from the base frame to frame 1. Okay, we apply that, okay, this transformation matrix. Okay, so from A0, from 0, A1, from frame 0 to frame 1. So we apply, we just substitute those equations, we'll get this. Okay, and frame 1 to frame 2, you get this. Frame 3 to frame 2 to frame 3, you get that. Yes, Mr. Timana.
Sir, may you repeat how you got the parameters for theta?
For theta?
Yes, sir. Can you go through it again?
Through it again. Okay.
Yes, sir. Just theta.
Okay. So let me do that. Erase. Let me erase all these so that we can. Start fresh. So, but then we put, I want to stay, we have a D1 here. So it's not 0, we have a D1 there. Okay. So let's do theta as requested by Mr. Timana. Okay, Timana, you must do a high score. Okay. Otherwise my repeat discussion will be not, will be in vain. Okay. Okay, now let's go theta. So, well, it's just a matter of following this convention, you know. It's a convention. We just follow the recipe. Okay, so now theta 1, yeah. Theta 1 is about Z0. Z0 from X0 to X1. Okay, so where is Z0? Z0 is here. Okay, let me change the color. Okay, this is Z0. So along Z, okay, so about Z0. So about Z0, Z is there, yeah? So you put your thumb on the axis, direction of the axis, and so the rotation will be like this, the positive rotation, yeah? So that's Z0. About Z0 from X0 to X1. Where is X0? X0 is here, yeah? So X0 is there. So you put these 4 fingers along X0, and this one along Z0, yeah? So now you sweep from X0 to X1. You sweep from X0 to X1 like this or like that, yeah? Because we sweep around about Z0. So it's like this and like that. But in this case here, in that drawing, there is no change. There's no rotation. So the rotation is 0. But we assign it to be theta 1 because in this case, theta 1 is variable. It will change. When it rotates, then there will be some value of theta. But now in this particular configuration, when the robot is configured like that, your theta 1 is variable, yes, but its value now is 0, because this is there's no sweep from x0 to x1. For example, if the robot rotated, if the robot was rotated, then you have some value with theta. Okay, so for those variables, what I want you to do is you assign the variables theta 1, theta 2, for example, just like this d3 or like that, because d3 in this case is a variable, but you put the value. Okay, if there's a value that's possible to put, then you do that. Otherwise, if it's hard to guess what's the value, 30 degrees like that, not very clear. Okay, unless it's 90 degrees, it's very clear, 30, 45 degrees. So it's not very clear from the drawing. You just write theta 1, it's fine. But in this case, theta 1 is equal to 0 because x0 and x1 are parallel. Is there a question on this one before we proceed? Mr. Timana. Okay, what I want you to do is put your finger up, your thumb. Put your thumb up like that, and then put the rest of the fingers pointing towards x0. Okay, so this is z0 and this is x0. Now sweep towards x1. Sweep towards x1, but x1 is also pointing there. X1 is also pointing there. So there is no rotation. Okay. What's the other before I go to theta 2? Tell me.
Sir?
Do you have concern with that explanation? Do you agree, or you have a question?
I agree, sir. It's good.
Okay, you agree. Okay, let's go to theta 2. So theta 2 about z1. So where is z1? This one. Okay, and theta 2 is, again, you put your finger towards z1. Yeah, z1 is there. Okay. Okay, from from x1, yeah, because this is xi minus 1. So from where is x1? X1 is there, flat. Okay, so your z1 is there, x1 is here in this direction, and then it says about z1 from x1 to x2. Again, you sweep towards x2. But when you sweep towards x2, x2 is parallel to x1. So there's no, you cannot sweep. It remains there. Okay. So that's why your theta 2 is equal to 0. But you put theta 2 as a variable because that's a variable, and that's also equal to 0. In the case of theta 3 is not a variable. So we don't assign it a variable just like this one. Okay. Here, D1 and D2, we assign D1 and D2 values, but these values are constant. These are constant values. And this one, D3, is the one that changes. Okay. But will it affect the transformation matrix here? It doesn't affect. You still put the same values. So the only difference is that every cycle, every step computation cycle, then those variables will change values. The rest of them will remain the same. So you update the computation based on the changes of, in this case, theta 1, theta 2, and D3. Then the rest of the equations will be the same. You're just putting in numbers, that's all. Okay, so let's check theta 3. Theta 3 is about Z2. So where is Z2? Z2 is up. Okay, about Z2 from X2 to X3. Where is X2? In that direction. So put your finger up about Z2. There's put your finger up, and then X2 is in this direction. And then you sweep towards X3. But again, X3 is in the same direction. So that's 0. Okay. Okay. Any more questions before I go to the next Example. Okay, I guess there's no more question. I want to move fast so that I can finish within time. Here on the spherical wrist, okay, this one, everything is a spherical, I mean a rotational joint. The other one joint is the same. You can see they're the same. This shoulder, this joint, and that joint, they're the same. The only difference is that here is a prismatic joint, here is a rotational joint. So let's see how does it change. Okay, so or maybe we do this so that it will be different for it's the same. The only difference is that here is rotating in the same axis, here is rotating in that axis. Anyway, so most of the thing will by theta 1, link 1, and link 2 will be the same, only theta 3 will change. But anyway, let's go here. So let's assign again, let's assign the axis where the frames. So in this case, this is your joint 1. It rotates about Z0. Your joint 2 here. Yeah, this is joint 2. So we just say joint 2 positive is in that direction. So that is Z1. Okay, I know now why the numbers are changing, because they're supposed to be a wrist. A wrist, that means after the arm, you put the wrist. Okay, but anyway, we will not do the 4, 5, and 6. We'll just do 1, 2, 3. Okay, it's just a matter of numbering. So the next part is here. So here, this joint rotates there. So, okay, let me just. This is the rotation of theta 1. Here, this is the rotation of theta 2. Undo. This is the rotation of theta 2. Okay, and then now this is your Z3, and also rotates. The positive direction is this direction, theta 3. Any questions there? No, not theta 3, but theta 2. Theta 3, that's correct. It's the one that is wrong, is this one. This is Z2. Okay, that's along Z2. And now where is your n effector? So Z2 and Z3 will be also in that direction. Okay, next we find where is the X. So X is again normal and intersecting to both Z. Okay, the Z I minus 1 and the ZI. Okay, so if you're looking again here, the base frame, we assign it to be, excuse me, we assign it before like this. So that is your X0. And we put your Y0 here. There. Okay. The next, where is your X1? That's the question. So X1, common, normal, and intersecting to both Z1 and Z0. Okay. So this is your, okay, this one should be around here. Intersection. Okay. So when you say X1, it will be normal to Z1, perpendicular to Z1. So where is Z1? This one. So X1 could be somewhere here. It could be somewhere here. This is one possible direction of X1 because that's perpendicular and intersecting to Z1, or it could be somewhere here. That's also perpendicular and intersecting to Z1. But there's another, it should be perpendicular and intersecting also to Z0. Okay, so is this intersecting? If this X is intersecting Z0, if this is our X1, yes. It is perpendicular to Z0, yes. So this is okay. But what about this one? Is it intersecting? There, it's coincident. And is it perpendicular? No. So this, we cannot use this. So we erase this. Okay. So now what we have is, now this is your x1. Okay. Why is your x1 in that direction? Can we have an x1 in the other direction? Of course you can. Yeah. So why don't we don't follow this convention? We put our x1 in the direction. It's fine. Okay.
Breath.
I don't want to use that positive direction. I want my positive direction to be not the same as the author. I put my x1 here. That's also okay. Okay. So what about x2? So now your x2 is common, normal, and intersecting to Z2 and Z1. Okay. So yeah. So your x2 is common, normal, and intersecting to Z1 and Z2. So this is your Z2. So we can assign our x2 to be along here. Yeah. To be, okay, let me put the yellow, to be along here or to be along here. Okay. But at which point? We don't know. It could be here. It could also be here with this requirement. Yeah, we don't know where is the point. But with the second requirement, it says it will be intersecting and perpendicular also to Z1. So where is your Z1? Here. So your x2 has to be intersecting and perpendicular to that. Okay, so that means that the x2 can be here or x2 can be there. Okay, but if x2 is here, does it intersect Z2? It does. Is it perpendicular to Z2? It is. Okay, what about this one? Is it perpendicular to Z2? No. Okay, so this direction you cannot do this. This one you cannot. These you cannot, these you cannot, these you cannot, these you cannot, because they don't intersect Z1. Okay, so this one you can, because it intersects Z1 and also perpendicular to Z1. And it also intersects Z2 and perpendicular to Z2. What about this one? This one you cannot. It's not perpendicular to Z2. It is coincident. So that means that your x, what is this now what we are looking for? Your x2. Your x2 will be here. You understand? Let me clear all this. Okay, so now you have your, okay, you have your x2 now, and your x1 is here. So x1, so that means let's just do the origin. So the origin of 0 is here. Okay, you know the origin of 1 is here already, because your Z1 is there and x1 is here. So now your x2 is here, and your Z2 is there, and your x2 is also there. So that means this is also the origin of frame 2. Okay. Then because you know the end effector, the hand is here, so we can just put your, this is Z3, so you make your x3 to be in the same direction. For us, we want to follow that x2, so your x3 will be there. Okay, their x6 is here. Okay, we can verify if it's possible to put x6 there, but for us, we've been doing this to just make the nth frame to be parallel to the n-1 frame. So it will be easier. But then our origin will be here. So that is the origin of frame 3, our n effector, where the hand is. Okay, so now we have completed all the frames. Okay, frame 0, 1, 2, and 3. So now let's look at the where is theta 1, alpha, where are the thetas, alphas, the parameters. So theta 1. So where is theta 1? So about z0. So that is z0, about z0 from x0 to x1. Where is x0? So x0 here to x1 is there. So about z0, again, your x0 is here to x1. Your x1 sweeps there in the positive direction. Can you do that? Put your z0 thumb there, and then put your x0 along the x0 axis, these fingers along the x0 axis, and then sweep to x1. So when you sweep to x1, that is pi over 2, positive. So this one, this is your theta 1. This is your theta 1, and this is equal to pi over 2. You see that? Okay, I will continue. Silence means yes. So about Z1. So we'll see theta 2 now. About Z1 from X1 to X2. So Z1 is here. Okay, from X1, where is your X1? X1 is there. Okay, X1 to X2. So X1 is flat, and then your Z1 is here, and you flat, and then you sweep to X2. So from X1 to X2 about Z1. So that is positive pi over 2 also. So this is theta 2. And this is pi over 2. Questions? No questions? Okay. Now about Z2, where is Z2? This is Z2. Z2 in that direction from X2 to X3. So where is your X2? X2 is on top, your X3 is there. Is the same direction. I mean, it's the same axis, parallel. So this one will be 0. We choose it to be like that. That one is 0. Okay, next, alpha. Alpha 1, about X1. So where is X1? X1 is there. Okay, so X1 is there, about X1 from Z0 to Z1. Where is Z0? So you rotate from X1. X1 is the thumb at X1, and then Z0 is this one to Z1. Z0 to Z1 about X1. So is that positive direction? That is positive. So that is positive pi over 2. Okay. Okay. Now look at this one. In the author, it is negative. Ours is positive. Do you know the reason? Ours is positive pi over 2. In the author, it's negative. Why? What is wrong? Are you following?
It's because our x is in
negative.
It's because our x is in the opposite direction of the x.
Correct. So if we assume, let's just assume for the sake of discussion to say our x1 is in the opposite direction. So we put your thumb there, and then z0 there, z0 to z1, you go here in the negative direction. Okay. So that's the reason why the author, we have different frame. The direction of our axis is different. Yeah. So you can assign it in any way direction that you have, as long as your parameters are correct. You assign the correct parameters. Okay, it will still eventually go to have the same value in terms of the end effector movement with respect to the base frame. Okay, so next, alpha 2. Alpha 2 about x2. Where is x2? X2 here. So x2, you put your thumb there. X2 from z1 to z2. So z1 is there, to z2 is here. Okay, from about x2, from z1 to z2. So that means what? Positive pi over 2. From there to sweep to there, that's positive pi over 2. So now it is positive pi over 2. This is correct. Okay, about alpha 3, about x3. So where is x3? Where is your x3? X3 is there. Okay, so x3, about x3 from z2 to z3. Nothing. No, they are the same direction. So that's 0. Okay. Next, let's do the D's. Yeah. So D1 along Z0. So this is Z0 along Z0 from origin of frame 0. Origin of frame 0 is, let me change the origin of frame 0 is there. Okay. Origin of frame 0 to intersection of Z0 and X1. So this is Z0, and what is your X1? This one. Intersection of Z0 and X1, that's the intersection. From here to there along Z0. So there's a distance here, D1. Okay, for us, there's a distance D1. So here, this should be a D1. Okay. Because we choose to assign our origin to be here. Next, along D2, so along Z1. So where is Z1? Here. Along Z1 from origin of frame 1. So origin of frame 1 is there to intersection of Z1 and X2. Z1 and X2 intersection is there. They're coincident. Okay, intersection of Z1 and X2. This is the one. And then the origin of frame 1 is there. So they're coincident. So that is 0. So what is this? Alpha, this is D1. I mean D2, that is 0. D2 along Z1, This is Z1, origin of frame 1, origin of frame 1 to intersection of Z1 and X2. So they are coincident. So that is 0. D2 is 0. Now D3, along Z2. So along Z2 from origin of frame 2. Origin of frame 2 is here. Okay, to intersection of Z2 and X3. Z2 is this one and X3 is this one. Okay, from here, origin of frame 2 to intersection of Z2 and X3. So from here to there along Z2. So this distance. So this distance is assigned to be D5, but we assign it, is this D5 or D6? I think that's D6, but we assign it to be D3 because we don't want to confuse ourselves in terms of indexing. So we put it D3. Okay, so now alphas. Okay, we're about to, after this, we'll have a break. So I'm sorry, alpha A1 along X1. Where is X1? Okay, X1 is here. Along X1 from intersection of Z0 and X1. So Z0 is here and X1 is there. That's the intersection. Z0 and X1, that's the intersection. To origin of frame 1. Frame 1 is the same. So that is 0. So A1 is 0. That's 0. Next, along A2, along X2. Where is X2? X2 is there. From intersection of Z1 and X2. So X2 is here. Where is Z1? Intersection of X2 and Z1, this one. Okay. And I mean, intersection of Z1 and X2 2 origin of frame 2. Origin of frame 2 is here, is the same. So that's also 0. Okay, next, A3 along X3. Where's X3? There. Intersection of Z2 and X3. So intersection of Z2 and X3, that's the one. Origin of frame 3, is that the one? That's also 0. Okay, finish. Okay, so with that, you know already. So each parameter you plug into this. So you have theta 1. So A0, A1. So when you have 0, A1, then you substitute there with theta 1, all this alpha 1, all the alpha 1, and D1 and the A1. Everything will follow because the I, this is according to the index here, to the subscript. Then you have those. So you have 0, A1, everything will be index 1. 1, A2, everything will be index 2. 2, A3, everything will be index 3. So here, so yeah, here we choose to have 0, A1. So this one should be C1, S1, everything like that. And then 1, A2. For us, this is 0, A1. And then the other one is 1, A2. And then here will be 2, A3. Any questions? And then multiplying all those, you have 0, A3, or we can say transformation from 0, A3 is equal to, 0, A1 times 1, A2 times 2, A3. Any questions? Okay, if no questions, let's have a break of 5 minutes, and then we'll come back at, what is this now? 12:08 plus 5, that's 13. Yeah, or let's just say 12:15. Okay. Okay. No questions? If no questions, we will have a break we will see you at 12:15.